For this next lesson, we're going to start looking at parabolas. We're not going to do a whole lot of calculations, and the calculations that we do are not going to be too terribly difficult. What we do want to learn about, though, is some new vocabulary that you've never seen before. So recall that a parabola is going to be the result of the formula y equals ax squared plus bx plus c. That's our quadratic formula, or that's our quadratic equation in standard form. We can also look at it as y equals a times x minus h squared plus k, but we're not going to do anything with that particular formula in this lesson. Now, the new terminology or the new vocabulary that we need to add is going to be focus and directrix. And these two are related to each other in that the parabola is basically going to wrap around a focus point or a focal point. And that focal point is going to be an equal distance away from the, if we're using the origin, the distance between the focus and the origin is going to be congruent to the distance between the origin and then a line called the directrix. Okay? And basically anywhere that we go on the parabola, that's always going to be true. So if we pick a point here, the line between the focus and the point on the parabola or the segment is going to be the same length as the segment between that point that's on the parabola and also, again, the directrix. Now, I don't have a great drawing here. Mine doesn't work for every single point, but when you look in the book, you'll be able to see how it doesn't matter where you're at on that parabola. The parabola is always going to be equidistant to both the focus and the directrix. Now, going back to geometry, remember that the shortest distance between a point and a line is a perpendicular line. So we know that these lines here, the green line here and the orange line here, are both going to be perpendicular to the directrix. Now, assuming that our parabola has a vertex at the origin, then what we're going to be looking at is that our focus is going to be the point 0, C. The C value, we're then going to go the opposite of that, and that's going to be where our directrix is located. So if this is 0, 3, then the directrix is going to be at y equals -3. So it's actually pretty easy to graph. You just have to remember the relationship between the focus and the directrix. Now, we do have another formula that we need to introduce, and this is y equals 1 over 4c x squared. So again, we've got basically something in our standard form. We're just not worrying about the bx and the c here. What we're going to do is we're going to use the c value of the focus, and we're going to plug that into the denominator here, and that's going to give us basically y equals ax squared plus c, or I'm sorry, y equals ax squared, and then we'd be able to draw a parabola that has either a compression or a stretch, but no horizontal or vertical movement. Because remember, with all we're doing here, we're always going to have our vertex at the origin. You're not going to have any other types of problems in this particular lesson. For problem number 1A and 1B, we're going to solve two problems that are related because we're going to be using this formula to find both solutions. Now, in problem number 1A, we're going to be given that the vertex of our parabola is at 0, 0, which I mentioned earlier. That's all that we're going to be working with in this lesson. Then the focus is at 0, 2. Now remember that this focus is going to be the point 0, C. So what we're going to do is we're going to replace 1 over 4c, that c is going to be replaced with that 2. And we're then going to have the formula or the equation for our parabola. So this is a pretty simple operation here. 1 over 4, replace the c with 2, and then tag on your x squared. So you end up with y equals 1 over 8 x squared. And so you know from earlier on, we're dealing with the a value. You know that since 1 over 8 is less than 1, we're going to end up with a compression, and it's going to be a pretty significant compression for our parabola. Now, remember that if this were asking for the directrix would be fairly easy to figure out because it's just going to be the opposite of that. So our directrix would be y equals -2, because we're just going the opposite of the y value of the focus. Now over on problem number 1b, this time we're given negative 1/12 x squared, and we're asked to find what is the value of the focus, or what is the ordered pair for the focus, and then what is the equation for the directrix. Pretty easy. We're going to take this 12, and we know that this denominator right here is originally 4c. So we're just going to take 4c and set it equal to 12. C is equal to 3, and so that means that our focus is at 0, 3. But because this starts off as a negative, this is where you got to kind of remember, you've got a negative right there, so that actually means that our focus is going to be 0, -3. And then the directrix is going to be the opposite of the -3, so y equals 3. So if you start off with the equation y equals negative 1/12 x squared, you could actually set this 4c equal to -12, and then the c is going to be -3, which then gives you the c value of the focus, and then you can arrive at the directrix based off of that. For problem number 2, the only thing that changes is that instead of having a vertical parabola, we're now going to have a horizontal parabola that opens up either to the left or the right. So with this, we're given the same piece of information here, that the vertex is going to be 0, 0. But this time, our directrix is that x is equal to 1.25. So let's think about this for a second. If we have x is equal to 1.25, then that means that our directrix is to the right of the y-axis. That means that the horizontal parabola has to open up to the left. That then tells us that our focus is going to be on the x-axis, but it's going to be on the x-axis in between the second and third quadrants instead of between the first and the fourth. Now, since again we do have the directrix, we can figure out what the focus is. But this time the focus is going to be, again, because it's on the x-axis, it's going to be negative 1.25. And then the y value is going to be 0. So what we're going to do is go ahead and set this up as x equals 1/4c y squared. Now we're going to plug in the negative 1.25 for the c value, and that's going to give us 1/4 times negative 1.25 y squared, and then we end up with 1/-5 y squared, or -1/5 y squared. So you can see there's the equation, there's the focus, and that's all based off this directrix and this vertex. Now coming over here to problem number 2b, this time we're given the equation x equals 0.75 y squared. And we're being asked to find the vertex, the focus, and the directrix. Now the vertex, simple, it's still going to be 0, 0. So we're just going to go ahead and write that in. Now to get the focus and the directrix, what we're going to do is we're going to say, we've got a decimal here instead of our fraction. What I'm going to look at is this right here, this 1/4c, is what this 0.75 is equal to. So that's the equation that I'm going to set up. So 1/4c is equal to 0.75. Now I prefer to work with fractions as opposed to decimals, so what I'm going to do here is I'm going to change the 0.75 over to a fraction. And that's going to give me 1/4c is equal to 3/4. Now at this point you should recognize that you've got a proportion. Anytime that we have a proportion, the rule is to go ahead and cross multiply. So we get 4c times 3 is 12c, and then 1 times 4 is 4, and then we get c is going to be equal to 4/12, and that's going to reduce then to 1/3. So the c value is going to be 1/3, which means that our focus is going to be at 1/3 and 0, and then our directrix is going to be at x equals -1/3.